All right, everybody. One more quick video today, just covering types of faults and a little bit more about earthquakes. Okay, so we've talked about S waves, P waves, love waves, Rayleigh waves. Looking at all these should be familiar. I'm going to quickly talk about the types of faults that we see that cause these kinds of earthquakes. All right. So faults have two sides. There's the crack, which is the actual fault, right? But on either side of the crack, you have two slabs of rock, and we can see this rock wall here. There is a very defined fault. Excuse me. Very defined fault. It runs right here. This is called the hanging wall, this portion of rock, and this portion of rock is called the footwall. The hanging wall is essentially the top part of the fault. So the slab of rock that is on top and the slab of rock that is on bottom is the footwall. So hanging wall, footwall, this will be important to distinguish between the two when we talk about the types of faults. So the hanging wall has its face pointing down, so it's laying on top of something, and the footwall has its face pointing up, so it has the other piece of rock on top of it. Okay? So these types of faults, there are different types. We have the normal fault, which is when the hanging wall, which is this portion of this fault, you can see the crack right here very clearly. The hanging wall moving down relative to the footwall indicates that it is a normal fault. So you can see this layer of rock right here and right here. Those two layers used to be together. It used to be a single continuous layer. You can see that this fault has moved the hanging wall down, and the footwall has moved up relative to the other wall. Okay, these layers, it can help us distinguish the movement of the fault. All right, generally this is caused by the two sides moving away from each other. So as they move away from each other, of course, this is kind of like sliding down a ramp, right? The hanging wall is essentially going down the ramp of the footwall. We here in Utah live in what's called the Great Basin. We actually have normal faults on both sides of the valley. So the valley that we live on is the hanging wall of both faults, and it is actually slipping down in between the mountains. So the difference in altitude between the mountain tops and the valley floor is actually growing, not because the mountains are going up, but because the valley floor is actually moving down over time. Don't worry, we're not going to fall into the core of the earth or anything. It's just we are simply sliding into a lower portion on the fault. All right. These oftentimes happen at divergent boundaries because the hanging wall is moving down, it's slipping down the slope of the footwall. Okay, that's a normal fault. Now, if we were to reverse this and the hanging wall was moving up, that would be called a reverse fault. All right. So here we see a normal fault in this image. Again, the hanging wall moving down, the footwall moving up relatively. And a reverse fault happens when the hanging wall is moving up relative to the footwall. So it's essentially being pushed up the ramp. This leads to sometimes being called a thrust fault. Okay, a thrust fault, because the hanging wall is being pushed up the ramp of the footwall. This usually happens at convergent plate boundaries or portions of the Earth's crust that are being pushed towards each other. Okay, this is a reverse fault. So we have a normal fault, we have a reverse fault, normal and reverse. Okay. Again, pause if you need to take a moment more to get your notes Transcurrent faults, also called strike slip faults. This is similar to a transform plate boundary because we have the portion of crust moving one way and the portion of crust moving the other. There is no vertical movement here. This is not a picture of layers of rock like a cliffside. This is looking down at a set of mountains from space. And this is the Pekiang fault, which I believe is in northern China. And you can see that this portion of the mountains here has very similar coloration, but there's this division where it looks like this portion has been moved up and this portion has been moved down. That is exactly what has occurred here. There is a fault that runs right here, and when these two slabs of Earth's crust move, this one moves up, this one moves down in this picture, right? North and south. And so they're sliding past each other. All right? So this is a strike slip or transcurrent fault. So we have the three types of faults: normal, reverse, and transcurrent. Normal and reverse are moving up or down relative to each other. A transcurrent is just moving side to side. They're moving past each other. Okay? They're not going over top or underneath one another. They are simply moving past one another. Okay, so when earthquakes occur, they can cause something that is very destructive that we call a tsunami. Some people call them tidal waves. I don't like to call them tidal waves because it doesn't have anything to do with the tides. So I avoid using that term. This is not a real picture, don't worry. I guarantee you that these people would not be so calm if this was a real picture. Someone has simply photoshopped in a regular size wave to make it look very, very large compared to this building and these people, okay? So don't worry, you're not watching the soon-to-be demise of these tourists in, I'm gonna assume this is Iceland, I don't know, okay? These tidal waves, as some people call them, but I prefer to use the term tsunami, are huge influxes of water. They look like waves. They're not really waves. They're kind of like the ocean water being sloshed around in a very violent way, and they can be extremely destructive. When we look at this here, this image is pretty obvious, the destructive power of a tsunami. These are relatively large boats and pieces of structures, homes, and so forth. These boats are just sitting on the land. Earthquakes can cause huge amounts of damage by themselves, but the tsunami that follows oftentimes makes even more damage because these waves can be up to 30 meters tall, which is about 100 feet. 100 feet is really tall. It's about as tall as some of the buildings here in Ogden, some of the tallest buildings here in Ogden. So imagine a wave moving at several hundred kilometers an hour that is 30 meters tall. And you can imagine the amount of damage that it can cause. The problem is that the earthquake area is not the only area affected by tsunami. The tsunami can travel across the ocean for long distances and hit areas that do not seem very close, right? They can destroy buildings, knock down entire houses, and sweep things out to sea because when the water comes onto the land, it has to go somewhere. So it recedes back into the ocean. And when it does that, it carries stuff from the land out to the ocean. The classic warning sign of a tsunami is that all of the water on the beach recedes. So it rushes out into the ocean as it is gathering speed and water away from the shoreline, and then it comes all crashing in. So if you're ever at a beach and you see the water line draw away from the coast very quickly, you need to get to higher ground as quickly as possible. All right, so that's what I wanted to cover to finish off earthquakes. So we've covered the fault types. 3 fault types, and the footwall and the hanging wall, footwall being the underside of the fault, the hanging wall being the upper side of the fault. Normal faults are when the hanging wall moves down. Reverse faults are when the hanging wall moves up. Transcurrent faults are when the crack is running through the earth and the 2 sides move past each other horizontally. Tidal waves, quote unquote, are actually called tsunami. So we'll use the term tsunami. They're huge waves that come in and can be very destructive. It can be very large, and they travel long distances. Yeah, all right. So that's what I wanted to cover to finish off our earthquakes. And make sure that this is in your notes, and I will talk to you all later. Bye.